before each night is done. Their plan will be unfurled by the dawning of the sun. They'll take over the world.
Hi, I'm Nili and I'm going to be a resident scientist in your school this year. I love living in Colorado. I grew up here and I love traveling and hiking, and I love living in Denver because I get to walk down a few blocks and I see beautiful views of the mountains and everything like this, but I still live close enough to the city that I can go into the city and do things. So I love living here. I like reading, I like playing the violin, and I design my own clothes sometimes. I have a big family, and it can be kind of crazy and chaotic when we all get together, but I enjoy spending time with them. And of course, I love science and math. When I was younger, I always liked trying to take things apart and figuring out, I would always try to figure out how things work. And I think that's one reason why I ended up becoming an engineer. Right now, I'm working on getting my master's degree in mechanical engineering from the University of Colorado, Denver. And what do engineers do? Engineers pretty much use science and math to innovate, to make new products and new buildings, and they use science and math also to solve problems and make sure that things are safe. And mechanical engineers, we specifically work on machines. So anything that moves, or even a few things that don't move, are worked on by mechanical engineers. So mechanical engineers might work on cars, or rockets, or even a turbine that produces electricity. One area of mechanical engineering that I particularly like is robotics. So there's so many really cool kinds of robots out there. There are flying robots, and there are robots that build things and help people, and there's a lot of really cool robots. But what I work on are robot hands that help people who lose a hand. So why don't we head over to my lab, and I'll show you some of the things I work on. As an engineer, as a mechanical engineer, a lot of the times we'll use computer programs like this to draw 3D models of things. This is just a really simple finger model I designed, and I have a gear here, and we're turning the finger and it moves it up and down. And I drew all these little parts. Here's our worm gear, and we can look at all the steps that it takes to make it. We can edit it. Here I kind of made my model a little crazier by changing the colors and the materials. The thing that I work on are hands, robotic hands for people who are amputees. So here's a really simple one that a lot of people have a similar type hand, just very basic, opens and closes. We kind of want something a little bit nicer, a little bit cooler, and a little bit more functional. Here's another kind of a simple one. Here's a kid's one, and a kid who used this hand, they would have this cable hooked up to a harness on their shoulder, and they would move their shoulder back and forth, and that would be how they would open and close this hand. We work on a little bit fancier, more complicated hands. This one looks pretty cool, I have to say. Even this one is not anywhere near as cool as we would like it to be. I'm going to turn it on, move the wrist around a little bit. Yeah, just like a regular wrist works, yeah? Maybe not. This is like for holding a key, maybe? Oh, this one is a mouse. Imagine if you're holding a mouse and you're clicking. Click, click. Okay. So I'd like to show you a little demo of conservation of angular momentum, which which is a mouthful. Pretty much what angular momentum means is just that when you're spinning really fast in a circle, you're going to continue in that circle. So when we're talking about conservation of angular momentum, if something's bigger, it's going to spin slower than something that's fast and small. So the smaller you are, the faster you spin. That's kind of why you see figure skaters, they tuck their arms in really small and when they want to spin fast. Snowboarders do the same thing, and even tornadoes, when they're real tight, they'll spin a lot faster than big, giant, wide tornadoes. What I'm going to show you is this little demo. I made a gyroscope out of a wheel. I popped off my bike, it's a little dirty, and I pretty much some tube and a piece of string. And we're just going to hold it up. And you see the wheel keeps itself up and rotates about that center rope. That was conservation of angular momentum. If you have questions for me about my research, about engineering, or this demo, feel free to let me know when I see you in school.